So we're starting back up here for part 2 at number 36. And again, we start to notice here we've got to know some of those words for add, subtract, multiply, and divide to make these work better for us. So at 36, we've got a product. What's a product stand for? Times, okay. So you can write this as 9a. You could write this as like a times 9, or you could write a in parentheses 9. Any of those work, okay? As long as you show me the fact that you understand that it's multiply. So it's multiply, we're good to go, okay? Nothing to solve, just writing what it is. 4 times the difference of x and 7. What's difference going to be? Difference is minus. And we kept talking about whenever we see sum or difference, that automatically means we're going to put parentheses around that part. So if x minus 7 is there, and again, 4 times it, can I put the 4 on the other side of the parentheses? Sure. Okay? But I've got to make sure the parentheses are there, because if they're not, then it makes life a little more complicated. Okay? Now we start to see who's on their A game. Okay, 38. We know less than would be minus. Here's the question, though. 8 minus x or x minus 8? Is this going to be 8 minus x, or is this going to be x minus 8? Minus 8. Because if I want 8 less, that means I want to take 8 away. That one I don't have a choice. If I write 8 minus x, that would be saying x less than a number 8. And I don't want that to happen. So I've got to remember on that one going to switch my order up. 39. Somebody willing to venture a guess what 39 is going to look like? Partially. Let me get the 13 and the x here. The is normally does do equals, but is no less than. So it has to be at least 13. Okay. Like this? The other way? Okay. Now let's talk about this for a minute. So let's say we looked at it this way. Now this is saying x is less than 13. So let's think about that for a minute. 13 is no less. There's a line underneath it. Okay, so here's our kind of quandary. Here's a little bit of a dilemma from what we left. That becomes the question. That's more of what I was looking for here. When you say 13 is no less than x, let's plug a number in for x for a minute. So let's say I plug in, I don't know, 15. Plug in a number that's bigger. 13 is no less than 15. Well, that's not right. Then 13 isn't less than 15. So what Martha's mentioned here is what we're going to do. If I switch this around, in this case now, you're like, well, but that says x is greater than or equal to 13. I see the word less, so why isn't the arrow pointing at it? We've got to think about what they're saying, though. They're not saying 13 is less than x, because then we want to get it that way. Is no less means it has to be more. And greater than is when the arrow eats x, okay? So the arrow eats x when it's greater than. And that's going to be tricky. That's the one thing that's tricky, that no kind of makes it the opposite of what we would think. That was one of the things we talked about a little bit. Okay? So, here's what I want you to do for just a second. Okay, I'm going to skip down to the bottom part. I'm going to come back to these couple, but I'm going to bring you down to the bottom here for a minute. Okay, remember, these are the diamond ones that we're trying to multiply to get the number on top, and we're trying to add to get the number on the bottom, and these two numbers have to do that for me. So like for instance, 3 plus what gets me to 9? 6. I want you to take a minute, do 44, 45, and 46. Okay? Don't tell everybody what the answer is yet. Don't do it quite yet. Just wait. We'll get there. We'll get there. But then if there's another part in 40 or 41 that you do know what's going on, go ahead and make sure that you got those double. Okay, and we can try to work on the here. $44, what do we got? 5. 8, I'm with you. 6. Okay. So the big thing with those is those two numbers on the side have to add up to the number on the bottom, but multiply to get the number on the top. So let's see here. Back up, we'll head back up to 40. Dustin wants to buy a bike. It's going to cost him at least $125. If X represents the money he needs, write it in the column to show how much money he needs. Okay, so we'll make Dustin D here. We know it's $125. So at least $125. Might it cost him $130? Okay, yeah, it might cost him $130. Well, could it cost him $90? No, because that wouldn't work. So which symbol do I need in here? Do I need greater than or less than? I need greater than. Okay? At least. It might cost him exactly $125. That's what I've got the line in here for. But it may cost him more. So if that happens, that's where the greater comes in. That's all I have to do. I don't have to do any solving or anything fancy. 41. The Smiths pay $1.50 per bag for candy at Harty's Party Store, plus a $10 fee for membership. C, I'm being told. I'm with you. Because what changes? How many bags I buy. So the variable goes with the 1 that changes here. And then the 10 is just what you pay no matter how many bags you end up buying, whether it's 1, 100, whatever it happens to be. Okay? So that works. That's good. One last one we got squeezed in here. The temperature was 70 degrees Fahrenheit and began to rise 3 degrees each hour. Write a variable expression. This is a lot like 41. Well, the temperature's 70. Okay, that didn't change. Depending on the number of hours, yes. Okay, plus 3x, because depending on how many hours have passed, the temperature's going to be that much higher. It's going to vary some. Okay? So that's what we're going to look at as we're working through those. All right, at the bottom, let's roll up to the top here on the next one. Michael's buying vehicles. Michael put $1,500 down on a used car. He took out a loan to pay off the balance of the cost of the car. His monthly payments will be $200. After 1 year, Michael says, oh my, Michael says that she has paid. That's not good. Michael says that he has paid $2,900 for the car so far. Is he correct? So let's think about this. Day 1 when he got the car, how much money did he give him? $1,500. Okay. How much is he going to pay every month? $200. Now here's where we got to think a little bit. After 1 year, how many monthly payments do you make in a year? 12. Yeah, if I work this out, 200 times 12 is 2,400. It looks like Michael didn't do his math quite right here, because it looks like he's going to be paying 3,900. When you see a question like this, there has to be more to it than just no, or yes, because I said so, or because he thinks that. No. We have to actually see why it is that it works up. It's just like number 48. Holly's Pizzeria. Shay and his 3 friends decided to divide the bill evenly. The total bill was $30. Shay says everyone should pay 10. Is he correct? Oh, now see, yeah, that's something we got to be careful of. Because sometimes we see 3 people, and we forget about the other person. So no, because I'd do $30 and there's 4 people. So how much should everybody pay? So we see what Shay is trying to pull here. If he tells everybody to pay $10, he's not going to pay nothing. He's one slick guy here. Hopefully somebody catches him. So again, not correct. We are just explaining why that happens to be the case. 49. John bought 11 watermelons and paid $39.50. How much did he pay per watermelon? Too much? Not one of the answers. How would I figure this out? Oh, did I not have the right answer here? Oh, did Harty not have the right answer here even? 359. Oh, geez. We're going to fix letter C here. Somebody put the wrong number in there. It can be determined, so we don't want to pick that one. Definitely didn't pay $28.50 for the watermelon. That's terrible. Yeah, my 0 turned into a 9. That's what needed to be. All right. We are going story problem crazy now. Gabe went to Woodman's to buy brats from Cookout. They sell the brats in 2 different types of packages. You can spend $3.97 for 2 pounds or $8.49 for 5. Which package is the better buy and why? Okay, first things first. If you take $3.97 and divide it by 2, what do you get? Okay, so like 198, 198 and a half, 199, somewhere in there. What if I switch up then and do 849 divided by 5? Which package is the better buy? This one. Why? Cheaper. Okay, but I'm just doing division here. And it's the same thing that I did over on the other one. Just take how much it is and divide by how many pounds you happen to have. Let me move that up some, because I know some of you are kind of peeking around here trying to see over my computer. We've also got number 51, and I remember when we were doing these before. Remember, any labels that are the same will cancel, and then we just multiply straight across. So what's $8 times 10? 80. $80 per room. Upset. Don't make those harder than they need to be. Just cancel things and multiply across. So we got to get down to a unit rate. We got to get down to out of 1. We're like, woo, we're heading towards the end. Then we just hit that middle part. We're good to go. All right. At the fair, the Spinorama ride does 90 rotations per minute. About how many times would you expect to spin per second? So let's see. Cross out the minutes. Okay. So if I multiply across, what do I end up with? So it looks like I have 90 rotations over 60 seconds. But the question is, how many am I doing per 1 second? How'd you get that? Perfect. 90 divided by 60, if I do that in the calculator, which is what I need to do, is 1.5 or 1.5. So I'll do 1.5 rotations in 1 second. And that's what I'm attempting to do. Now, some of you that were here when we did a couple of these, this will be a little bit easier. If not, let's see what we can do. You notice we start with hours and days. Then we end up with hours and weeks. So I want my hours to stay. That's good. I want days to go away. So if I put days up here, I'll be able to cancel those. And we put a week underneath it because I want that label to be there at the end. Okay? But, and you can, because how many days are there in a week? 7 days in 1 week. And then you're like, well, what else do I have to do? There's nothing else you have to do, because 24 times 7 is 168. 1 times 1 is 1, and I've got my 2 labels left. So sometimes you're just getting the middle part. You're not necessarily having to get the answer to everything. So then we get down to 54. And I'm not going to worry as much about this part for a minute. I want to get to miles and minutes. Well, right now, miles is good. Ooh, I don't want minutes. I mean, I do want minutes. Oh my gracious, Harty. How do I get rid of hours? Okay, put the hours on top, and if I want the minutes to stay, I will put the minutes on the bottom. So how many minutes are in an hour? 60. 60 minutes in 1 hour. Okay. Cancel out my hours. So I multiply across, and I've got 30 miles over 60 minutes. But again, I want to know how many miles I can do in 1 minute or per minute. So what's 30 divided by 60? 0.5. So I can do half a mile in a minute. That's pretty darn fast, actually. But that's how those work. And just like I did up here, I will give you labels for the ones that you need in case you need them when we go on the test. All right, 55. And then we might be ready to jump back into that other sheet here quick. Brandy bought some material for $2 per yard. She's going to cut them up $2 per yard, and I've got 560 here. Harty, what are you doing? She's going to cut them up into ribbons to raise cancer awareness. Find out how many cents per inch the material costs so she can determine how much to charge for them. Round your answer to the nearest penny. Okay, so I have yards, and I want to get to inches. So look at that little box up at the top of the page. How many yards are there? I mean, how many inches, excuse me, are there in a yard? Okay, so I don't want yards. So I put the yard up here. Okay, we're going to get there, though, because you're right. You look at this, and we're used to multiplying across at this point, but you're like, wait a minute, I still have dollars in inches. Well, I don't want dollars. I want cents. So how many cents are there in a dollar? 100. So here, I'm going to have $1 is 100 cents because I want the dollar signs to go away. So we had to do 2 separate ones because I wanted to change both of the labels. So now I have cents on top. I have inches on the bottom. This is good. So I'm going to multiply across. So 2 times 1 times 100 is 200. 36 times 1 is 36. But I want to know how much it costs per inch. So I need to know what 200 divided by 36 is. That'll go up top. Okay, so about 5.5 cents per inch. But these are the type problems, again, that we take one quantity and get it into the quantity that we want. And sometimes stores don't put it in the quantity that we want. Right here, 1 yard is 36 inches. Okay. So now, the sheet that you just got on the pickup today, a little bit back here with these. Make that a little bit bigger so it's a little easier to see. Okay. Substitution, I'll keep saying what I said before. Parentheses are your friend on this. The calculator actually can be too. For instance, here, I'm going to have 6 squared minus 4 squared divided by negative 4. Here's my suggestion for most of you. Most of you are fine doing perfect squares. Some of you, maybe not so much. So here's what I would do. I would cover up the denominator, and I would go ahead and punch the rest into the calculator. So for instance, here I would punch in 6 squared minus 4 squared. And that tells me it's 20. So I go ahead and I put in the 20. Now I bring the negative 4 back. 20 divided by negative 4 is negative 5, and I'm good. And that's all I'm going to do all the way across. It's in one line. Let the calculator do its thing. Negative 4 with the parentheses, squared plus 6 squared. If you punch that exact thing into your calculator, good question. Let me explain why I put them in parentheses. Well, let's see. Let's say I don't put that in parentheses. I do negative 4 squared plus 6 squared. Well, that says it. Oops. Move that over a little bit. Calculator says it's 20. Harty just. Okay, but that's back. I'm talking about this one. But what I'm saying is, if I don't put the parentheses, notice I didn't get the same answer. Because here's what happens. Here's how math is kind of funny. If you have what seems to be the same thing, I have negative 4 squared, or I have negative 4 squared. They're actually two completely different things. Negative 4 in parentheses squared means I want negative 4 times negative 4, which is positive 16. But if it's just negative 4 squared, I do 4 squared, which is 16, and then I put the negative back on. Okay, let me put the parentheses. Let's see what happens there. Negative 4 squared plus 6 squared. Are you putting your squared outside the parentheses? That's what I'm wondering. Okay. Because if it comes up like that, it should be coming up that way. If it comes up negative again, leave it there and I'll come see what happens. Did it work that time? Okay. But that's why I have to have the parentheses, because those values tend to change otherwise. Okay. Same thing working on 13. Okay. See, if I'm just adding and subtracting, it's not as bad. But here's another one of those issues. Instead of trying to type that in the calculator one big bunch, because I bet you something bad's going to happen, take it a piece at a time. And if you still want to go to the calculator, you can. But if you put each individual part in, 6 minus 8, and then hit enter, and then switch it up, 4 plus 4, hit enter. I've got to still reduce this, though. Anybody remember what buttons I hit to reduce a fraction? Okay? If I'm not sure, and it is. If I hit math enter, enter, it will reduce the fraction all the way down for me. You can get fractions. If the problem starts in a fractional form, I really want you to keep it as a fraction and not like 0.25. Dang it. Negative 0.25, right. And the same goes with any of these. Okay? If h of x equals this, what's the value? In other words, take that negative 6 and plug it in for x. Now here's one thing I'm going to make a suggestion on. When you plug in negative 6, since 2/3 is a fraction, make this a fraction as well. And here's why I think consider doing that. 2 times negative 6 is negative 12. divided by 3. So negative 12 divided by 3 is negative 4. I was going to say, especially those of you that haven't been here, I don't know, maybe you're experts, but I'm still going to be bringing this your way tomorrow. I'd be jotting stuff down and kind of seeing what's up. You'll find out. The thing with the whole deal with doing the parentheses and stuff. The negative 6 substitutes in where the x does. Whatever number they put in this parenthesis here is what I'm plugging in for x. So like this one said h of 4, I'm plugging up 4 for the x. Because I can make any whole number a fraction by putting it over 1. But if I didn't, if I just did this, I can get the same thing. Let me scooch this over so we can actually fit on here. I could do 2 divided by 3 times negative 6. Okay, I can still do it on the calculator, and then just plus the 6, and I get the same thing. So if you're more comfortable doing it this way, that's okay. Yes, ma'am. Okay, when I get down to here, whatever letter they put with x here, I'm not really worrying about. So I'm just looking at this part. Oops, I'm sorry. I've moved it back over and I forgot to come back. Just the part here after the equals is where I'd be plugging the number into my x. So here I'm going to plug the 5 in there. So I'd have 5 squared plus 5. And again, I can type that into the calculator, or if I know that 5 squared is 25, I can just add that up. And the one other thing I will have for you tomorrow, because I'd already said when it got to be the radical part, I'd have the radicals up for you. The other thing I'll do is the properties, because the 3 that we've talked about, let me kind of open this up. Whoa, there it went. Gotta move my computer here. The one I would hope you'd be okay with is where you distribute, just like we've done before. So the distributive property. The one where you see parentheses, where the grouping is different, is called associative. Now, if you just want to put like ASSOC, that's fine. But that's the grouping one. I can't put grouping, but it might help me remember which one it is. And the one where order changes is commutative. And if you just wanted to put CUMM, somebody mentioned in 7th hour yesterday, and I like the way he remembered it. He goes, I remember it is, you need to have order in the community. Well, he goes, commutative isn't quite community, but it's close enough that I can remember. I'm like, that seems sensible. So that might be a good way to help remember that one. So then for 19, which property expresses the distributive? Which one of those shows distributive? It is. Let's see, I'd have to multiply through there. And then at the bottom, we're just getting answers. So here, actually, I just get to add them all up. I don't even have to think a whole lot here. So add those up, I'd get 35. 21's nice too, because I don't have to worry about order of operations, it's all multiplied. So 32 times 5 is 160. I think that's 480. Just multiplying across there. Now 22, I have to think a little. I see add, I see divide, and I see add. What do I have to do first? I have to divide first. Because once I divide, now I can just add them up. 19 and 8 is 27. Now, like I said, the test itself will be this length, this type of question, this order, number of multiple choices will be the same, all that stuff. We're going to start tomorrow, and then we'll finish up on Thursday along with the homework check. So I'll have this back up tomorrow too, so you can just kind of see what you need to be kind of keeping up with. But we will start that just to see where everybody's at. So